Types of drawings. In this topic, you will learn important types of drawings which engineers should be aware of while working in an industry. Along with this, you will understand creators and consumers of various drawings, usage or application of various types of drawing with example. Let's take a tour of typical discrete manufacturing company. It generally has following departments, not limited to product development. This department is responsible for design and development of product. Production. This department is responsible for actual manufacturing of goods. Store. This department is responsible for keeping and maintaining raw material required for manufacturing as per their schedule. Quality. This department is responsible for overall quality management of product or finished goods. Tool room and maintenance. This department is responsible for helping production team with required tools and maintaining machines used for manufacturing. Production planning. This department is responsible for planning and optimizing existing assets and manufacturing processes for improved output. Procurement. This department is responsible for vendor management and procuring all material required for manufacturing as per their schedule. Part drawing. We have learned that uniqueness of an engineered part is defined by its form, fit, feature, and intended function to perform. Let's understand this with an example of a connecting rod. This means that for a specific part to perform its desired function, it must conform to its design fit, in other words, tolerances. Its form, that is geometry, and dimensions, and some unique specification such as material type, surface treatment and coatings, hardness, surface finish, etc. All of these details, when described for a part in a drawing, is known as the part drawing. Part drawings are applicable for engineered parts. If some specific custom features are added to standard parts, such as non-standard head or shank size of a bolt, non-standard thickness and diameter of a washer, etc., then such parts also become engineered parts. As we understood that a part drawing necessarily contains detailed information such as geometry, dimensions, tolerances, specific features. Note: standard parts like screws, nuts, washers, etc. are generally available based on standards and specifications of international accreditation. With this, now let us discuss the general application of a part drawing. Used for manufacturing the part under the stipulated guidelines indicated in the part number. Dimensions and tolerances in part drawing is used by quality department to ensure adherence of guidelines as described in the drawing. Part drawing also helps in developing manufacturing drawings such as jigs, fixtures, dies, part holding devices, etc. If the part requires to be developed by a supplier rather manufacturing in-house, this is shared by procurement with the supplier. Part drawings also leads to the development of raw part drawings, such as for raw materials that feed forging, castings, etc. Drawings of semi-finished parts, partially finished parts supplied by third-party suppliers, that is further processed in-house to produce the finished part, are also developed using finished part drawings. These are created by the planning department. Assembly drawing. An assembly drawing is a drawing of a product, subassembly or system with all of its components located and identified. The purpose of an assembly drawing is to show how the individual parts fit together. Note: a design engineer creates an assembly drawing. Typically, assembly drawings contains information on part used in assembly, that is part numbers, their usage, count of part used in assembly, bill of material, and sometimes also depicts where used. As part drawings refer to part numbers, similarly, assembly drawings also refer to assembly part number. Note: an assembly drawing along with its associated bill of materials also helps in defining the assembly sequence. Normally, in case of complex products, it is difficult to accommodate all details into one assembly drawing. Thus, in such cases, assembly drawing of such products may refer to multiple subassemblies. For example, it will be difficult to expect a single assembly drawing for a product like a car. However, a car top-level assembly drawing will have references to multiple subassemblies like engine assembly, body assembly, transmission assembly, etc. in the form of a general arrangement drawing. For example, in a large and complex assembly like a tractor, its subassembly drawings will refer to multiple other sub-assembly drawings, such as the engine assembly will refer to crankcase assembly, cylinder block assembly, etc., which further refers to connecting rod assembly, flywheel assembly, etc. Vendor or supplier parts are defined as parts which are manufactured by external entities and delivered to the original equipment manufacturer or OEM production line based on predefined design specifications. For example, a fuel injection pump supplied to a car manufacturer or a headlamps, windshield or glass windows, tires, etc. Often, manufacturing companies outsource their engineered part to their suppliers because of multiple reasons such as unavailable capacity, increased demand, cost, strategic intents, etc. Sometimes, the item design and drawings are the intellectual property of the supplier as they are engineered and created by suppliers and not the original equipment manufacturing companies ordering such items. The original equipment manufacturing company just receives such items with agreed specifications, fit, form, function, and standards adhered by the suppliers. Note: we shall discuss in our upcoming lessons the details of managing drawings and part numbers in such situations. For every supplier part, the original equipment manufacturer defines a condition of supply. This leads to mainly two broad categories of supply. First, when the original equipment manufacturer supplies drawings of a finished part to the supplier, then the condition of supply is finish. Here, we have taken the example of a headlight assembly. This part, received from the supplier, directly goes to the assembly line without any further processing. Here, the supplier is obliged to supply the finished part to the original equipment manufacturer with all quality checks done in line with the original equipment manufacturer's drawings. Many a times, semi-finished part drawings are also created by original equipment manufacturer and shared with suppliers for necessary supplies. This condition of supply is semi-finish. The part received here from the supplier undergoes further processing on the original equipment manufacturer's production line before being assembled into the final product. In all such cases, the drawing created remains solely the original equipment manufacturer's property and not the supplier's. Another version of supplier part is raw part. This follows the same approach as that of a semi-finished parts. Examples may be say forging, casting, supplied to customer by suppliers. Here too, the raw part drawing is created by ordering companies in reference to finished part drawing. Note, in all cases, the part acceptance criteria is directly dependent upon the drawing details provided to or by the supplier or vendor through the engineering drawing. An electric or electronic drawing is a simple visual representation of the physical connections and physical layout of an electrical or electronic system or circuit. It shows how the electrical wires are interconnected and can also show where fixtures and components may be connected to the system. Note, these diagrams do not depict items to scale. However, they are design information drawings. Wiring diagrams can assist in building or manufacturing the circuit or electronic device. They are also useful for making repairs. Electrical drafters prepare wiring diagrams used by workers who erect, install, and repair electrical equipment and wiring across various systems. Typical application of electrical and electronic drawing is wire harness drawing, cable assembly drawing, printed board drawing sets, microcircuit drawing. An installation drawing provides information for properly positioning and installing items relative to their supporting structure and adjacent items as applicable. This information may include dimensional data, hardware descriptions, and general configuration information for the installation site. Installation drawing typically has the following information: allowance for inclusion of all supports and fixtures necessary to install the works. Installation details provided from shop drawings. Installation working space to facilitate commissioning and space to allow ongoing operation and maintenance in accordance with their relevant health and safety requirements. A schematic is defined as a picture that shows something in a simple way using symbols. A drawing showing all significant components, parts, or tasks and their interconnections of a circuit, device, flow, process, or project by means of standard symbols is called schematic drawing. When operating principles cannot be readily determined from a study of the assembly drawing, a mechanical schematic diagram is prepared to illustrate design information for any of the following: hydraulic or pneumatic systems, complex mechanical systems, complex arrangement of gears, clutches, linkages, cams, etc. Rigging instructions involving wires, cables, rope, etc. Types of drawings. Also, as a drawing creator, one will understand the importance of thinking about the end user who will refer the drawing to complete his work.